Hey math fans! Welcome to Math Olympiad Academy, your trusted space for advanced problem solving and logical reasoning. We sincerely thank our subscribers and all viewers for your continued support. In Lesson 22, we present a rigorous, step-by-step solution to a definite integral that appears challenging to many students, but becomes straightforward once you recognize the inverse tangent pattern. In this problem, let j equal the definite integral from 0 to 1/2 of 1 over 12x squared plus 3 dx. Can you determine the integral j? Our objective is to grasp the method of integrating rational functions that lead to inverse tangent antiderivatives, and then compute the exact value of this integral. Before we begin solving, let's recall some basics about the definite integral denoted j. The expression 1 over 12x squared plus 3 is called the integrand, and dx is the differential. The number 0 is the lower limit of integration, and 1/2 is the upper limit of integration. Also, a natural question arises. Where should we begin? Begin by factoring the denominator of the integrand. 1 over 12x squared plus 3 equals 1 over the quantity 3 times the quantity 4x squared plus 1, which is also equal to 1 over the quantity 3 times the quantity 2 squared times x squared plus 1. In other words, the integrand can be written as 1 over 3 times the quantity 2x squared plus 1. In step 2, we prepare to integrate the integrand. 1 over the quantity 3 times the quantity 2x, all squared, plus 1, from 0 to 1/2. Since 1 over 3 is a constant, we move it outside the integral. This gives j equals 1 over 3 times the integral of 1 over the quantity 2x, all squared, plus 1, from 0 to 1/2. Now, in step 3, we apply the method of substitution. Let u equal 2x. Then du equals 2 dx, which means dx equals 1/2 du. We also re-express the limits of integration in terms of u. When x equals 0, u equals 0. When x equals 1/2, u equals 2 times 1/2, which is 1. So the new lower limit is 0, and the new upper limit is 1. Now substitute into the expression for j. J equals 1 over 3 times the integral from 0 to 1 of 1 over the quantity u squared plus 1 times 1/2 du. Since 1/2 is a constant, we move it outside the integral. This gives j equals 1 over 3 times 1 over 2 times the integral from 0 to 1 of 1 over the quantity u squared plus 1 du. Simplifying the constants. 1 over 3 times 1 over 2 equals 1 over 6. So, j equals 1 over 6 times the integral from 0 to 1 of 1 over the quantity u squared plus 1 du. Now, let's recall that the derivative of arctangent of u is 1 over the quantity u squared plus 1. Applying this, we have j equals 1 over 6 times the integral from 0 to 1 of 1 over the quantity u squared plus 1 du. This evaluates to j equals 1 over 6 times the quantity arctangent of u evaluated from 0 to 1. Using the fundamental theorem of calculus, this gives j equals 1 over 6 times the quantity arctangent of 1 minus arctangent of 0. We know that arctangent of 1 equals pi over 4, and arctangent of 0 equals 0. So j equals 1 over 6 times the quantity pi over 4 minus 0, which simplifies to 1 over 6 times pi over 4. By multiplying 1 over 6 and pi over 4, we find that j equals pi over 24. Therefore, j equals pi over 24. In conclusion, The definite integral of 1 over 12x squared plus 3 from 0 to 1/2 equals pi over 24. I hope you enjoyed this step-by-step solution. Keep practicing, share this lesson with your friends, and don't forget to subscribe to Math Olympiad Academy for more exciting math challenges. See you in the next lesson!